The integration of artificial intelligence across multiple domains has emphasized the importance of replicating human-like cognitive processes in AI. This work develops a methodology for modeling psychological disorders using reinforcement learning (RL) agents, incorporating emotional intelligence to evaluate their emotional stability and enhance their resilience in critical decision-making tasks. The authors propose an appraisal-guided proximal policy optimization (AG-PPO) algorithm, which utilizes appraisal theory to train RL agents in a dynamic grid world environment. The AG-PPO algorithm is designed to simulate psychological disorders, such as anxiety and obsessive-compulsive disorder (OCD), by regulating the behavior of agents through various reward-shaping strategies. The authors compared different configurations of the modified PPO algorithm, identifying variants that simulate anxiety and OCD-like behavior in agents. They also compare the standard PPO algorithm with AG-PPO and its configurations, highlighting the performance improvement in terms of generalization capabilities. The authors formulate 6 cognitive appraisals obtained from the grid world environment, representing the psychological state of the agent. These appraisals involve subjective evaluations of personal significance and implications of events, which are difficult to quantify and represent computationally. The AG-PPO algorithm effectively grasps and uses diverse appraisal dimensions, bridging qualitative appraisals with quantitative RL. The author's key contributions include the development of the AG-PPO algorithm, which can train an emotional agent in a dynamic grid world with cognitive appraisals. They also showcase a variant of the AG-PPO algorithm that surpasses the performance of the standard PPO algorithm in the selected dynamic grid world environment. The work aims to propose a new research direction in exploring the psychology of RL agents, without asserting that these agents possess human-level emotions or intricate psychological disorders. The author's approach involves evaluating psychological disorders in RL agents, which requires reliable and valid metrics to determine the presence and severity of these disorders. They conduct an analysis of the agent's behavioral patterns in complex test environments to evaluate the associated symptoms corresponding to the psychological disorders. Overall, the work showcases the benefits of the appraisal-guided PPO algorithm over the standard PPO algorithm and the potential to simulate psychological disorders in a controlled artificial environment. This study introduces a novel approach to reinforcement learning by incorporating cognitive appraisals into the Proximal Policy Optimization (PPO) framework. Cognitive appraisals are variables that influence an agent's decision-making process, including motivational relevance, novelty, certainty, goal congruence, coping potential, and anticipation. These appraisals are estimated at each agent step and are used to shape the agent's actions and value estimation. The study defines each appraisal variable mathematically, using equations to calculate their values based on the agent's position, goal state, and other environmental factors. For example, motivational relevance is calculated as the complement of the Manhattan distance between the agent and goal in the grid world, while certainty is estimated using the entropy of the soft-max applied output of the actor network. The study also introduces a reward-shaping strategy, which modifies the immediate rewards using cognitive appraisals to guide the agent's learning and exploration. 10 different configurations are experimented with, including a baseline and control, as well as multiple variants using reward shaping. Each configuration is designed to test the effectiveness of different appraisal variables and reward shaping strategies. The study adapts the standard PPO algorithm by incorporating cognitive appraisal variables into the critic network. The modified approach uses a convolution network to process state information and appraisal variables, which are then used to estimate the value function. The policy loss is estimated using the clipped surrogate objective function, which measures the policy's deviation from its previous policy. The study also presents an algorithm for the modified cognitive appraisal-guided PPO, which includes initialization, observation, action selection, and policy updates. The algorithm uses generalized advantage estimation (GAI) to estimate the advantages, which are then used to train the actor and critic models. Overall, this study introduces a novel approach to reinforcement learning by incorporating cognitive appraisals into the PPO framework. The study demonstrates the effectiveness of different appraisal variables and reward shaping strategies in improving the agent's performance and adaptability. The paper discusses the integration of cognitive appraisals into reinforcement learning (RL) agents to enhance their performance and generalization in grid-world environments. The baseline configuration, utilizing a standard PPO algorithm, demonstrates robust performance in learning environment dynamics and agent adaptability. The RSV1 configuration, incorporating motivational relevance for reward shaping, exhibits superior generalization during training and testing in both GWA and GWB environments, surpassing the baseline and PPO plus appraisal. This integration enhances PPO algorithm performance and generalization, guiding agents towards successful goal attainment. The overall score is computed using equation 19, and Table 2 summarizes scores for all configurations. RSV1 emerges as the top configuration, excelling in both GWA and GWB. Indicators like stress, aversion, and distraction are also taken into account to analyze agent behavior. Equation 20 illustrates how to use weighted cognitive appraisals to estimate stress. Aversions are measured by keeping note of complete turnaround followed by onward motions, whereas distractions entail instances of losing sight of the goal post-initial encounter. Table 1 demonstrates that the RSV7A agent shows repetitive behavior patterns resembling OCD symptoms, including adherence to non-contributory action sequences, alongside heightened distractions and stress. This suggests the presence of anxiety and OCD-like traits, where internal compulsive tendencies drive the agent's goal-irrelevant compulsions. The RSV7B agent's preference for preferring the grid's edges reflects its cautious avoidance behavior, resembling traits seen in anxiety disorder. This inclination to stick to edges, even when shorter paths exist, demonstrates a strategy aimed at minimizing potential obstacles encountered within the grid's interior. The references provided on pages 7 and 8 of the research paper offer a comprehensive overview of the existing literature on emotion, cognition, and artificial intelligence. The citations span multiple fields, including psychology, neuroscience, computer science, and engineering, highlighting the interdisciplinary nature of the research. The references cover various topics, such as emotion regulation, Gross, 1998, Lazarus, 1991, Cognitive Antecedents and Consequences of Emotion, Grach et al., 2009, and Effective Computing, Picard, 2000. The citations also touch on reinforcement learning, Sutton and Bartow, 1998, Schulman et al., 2017, deep learning, Vaswani et al., 2017, Devlin et al., 2018, and natural language processing, Wang et al., 2018. Furthermore, the references discuss the importance of emotional intelligence in human-computer interaction, Peter and Beal, 2008, and the challenges of developing emotional AI systems, Gremsel and Holzel, 2022. The citations also highlight the significance of cognitive psychology in understanding human emotions and behavior, Ortony et al., 2022, Kensinger, 2004. The references also include papers on specific applications of AI, such as reward shaping in reinforcement learning, Gupta et al., 2022, Memarian et al., 2021, and the use of transformers for image recognition, Dosevitsky et al., 2020. Additionally, the citations cover various psychological and neurological disorders, such as obsessive-compulsive disorder, Leckman et al., 1997, and generalized anxiety disorder, Stein and Serene, 2015. Overall, the references demonstrate a thorough understanding of the existing literature on emotion, cognition, and AI, highlighting the complexity and interdisciplinary nature of the research. The citations provide a solid foundation for the development of novel AI systems that can understand and interact with human emotions.